Okay, welcome back if you've been here before, and welcome. If this is your first time for one of these videos. Accelerated Math Objective Arc Length. Alright, this one can be a little complicated, so I got three different examples. For a circle of radius 7 feet, find the arc length of a central angle of 12 degrees. We learned a long time ago that the central angle is anything that starts at the center of the circle. This is not to scale, but anyway, I got this arc length with a central angle of 12 degrees. So I'm going to go ahead and label this, draw a diagram, because anytime you do these word problems, it's best to draw a diagram so you can kind of visualize it. Okay, the radius is 7 feet, and they want to know this arc length. Well, our formula for arc length is the arc degrees over 360 times the circumference. The circumference, again, is the distance all the way around the circle, and that is 2 pi r, or pi d. In this case, they're giving me the radius, so I'm going to use 2 pi r formula. And we want to know just that little segment right here, so we're going to say that we want the arc degrees over 360, that gives us a little fraction, times 2 pi r. So it's the circumference formula times this little fraction, and let's put it into practice, and it might make a little more sense. The arc degrees is 12 degrees, and the whole circle is 360, so it's just giving us the fraction of the circle that they're asking about. And of course 2 pi r in this case is 2 pi times 7. And I want you to notice that the answers up here are in fractional format, and they include pi. So we're not going to have to use a calculator to simplify the pi value. We're just going to leave pi in there because that's what the answers look like. And it could be that one too, I guess. Alright, so let's continue this. And this is easier than you think, really. So this is the same thing as 12 over 360. I'm going to expand this a little bit and put this 2 pi 7 or 2 pi r up here and over 1, and now I'm just going to multiply across everything on the top. So 12 times 2 is 24, and 24 times 7, well, I think that's 168, but 24 times 7, yep, 168. So 168 pi, and I left pi in there because the answers are leaving pi in there, over 360. That should be my answer, but there isn't anything like that, which means that 168 over 360 reduces. And let's just think of some things that go into both 168 and 360. Well, they're both divisible by 2. So I'm going to just kind of do it the long way here. 84 pi over 180. Those are both divisible by 2. I could use a calculator if I needed to. 42, in fact, it's kind of safe if you do it that way. I'm not doing it in here. 42 over 5, those are both divisible by 2, so I'm going to continue. That's 21 pi over 45. Now, let's see, what goes into both of those? 3, I believe, goes into both of those. So let's pull it over here a little bit. 3 goes into 21 7 times, so 7 pi, and 3 goes into 45, 15. Again, I could use a calculator if I wanted to, but that's basically my answer, other than the fact that it has feet in it, so I need to put those feet in there. And that's a strange looking answer. It's left in terms of pi. If you really wanted to know how many feet, like you actually had to measure it out, you would do 7 times 3.14 on the top divided by 15, so it was 1.4 feet. Alright, this is the critical part of this, knowing that formula. Alright, let's go on to the next one. We're going to use the same formula. Arc length. They want to know the arc length of a sector of a circle. A sector is just a little segment like a pizza slice. Okay. Well, no, I'm sorry. The arc length of a sector is 10 pi. So they're telling me that this is 10 pi from there to there. And let's see, they give me a radius of 36 centimeters. But they want to know the angle measurement, so I'm going to put an X there. They want to know that. If you recall, our formula was the arc length is equal to arc in degrees over 360 times the circumference. And the circumference is 2 pi r. I could have used pi d, but in this case they gave me a radius, so I'm going to use that arc length. They told us the arc length was 10 pi. Makes me feel a little uncomfortable with that pi in there because it's kind of strange, but it's in there. Let's see, arc degrees, in this case, I don't know, so I'm going to put the x over there, 360 times 2 pi, and the radius they did tell me was 36. Alright, let me simplify what I can to start with. So 10 pi equals x over 360 times 72 pi. I'm going to drop a 1 under there. Alright, and try to simplify this side. I'm going to have to solve for x at some point. So let me just see if I can simplify this at all. 72, how many times does that go into 360? So I'm going to do a little 360 divided by 72. It goes in 5 times. So 72 goes in that once and 5 times there. So this whole side over here kind of simplified to x pi over 5, if you will. And so I'm going to scratch that out a little bit, equals 10 pi over here. How do I get rid of this pi on this side? Well, I divide this side by pi and it cancels it out, but I have to divide this side by pi, and look, it cancels that out. That's kind of cool because now I'm not frustrated or confused with that whole pi thing in there. So 10 is equal to x over 5. How do you get rid of divided by 5? Well, you multiply both sides by 5. Multiply both sides by 5. That cancels that out. I got x equals 50. That's telling me that arc degrees is 50 degrees. Woo! Last one on this one. Good thing is you can replay if you need to see. I know I was going through that kind of fast. The measure of a central angle of a sector is 144. Let me try to draw this somewhat to scale. The arc length is 144 degrees. Right, the arc length of the sector is 12 pi. So 12 pi, there's that pi again. Makes me feel a little confused right off the bat, but let's see if we can deal with it. And they want to know what is the radius. So I'm going to put an r there. I could put an x, but I'm going to put the r there. So our formula was arc length. Obviously, I've 3 times in a row I've written this formula, so you probably need to know this one. Arc length equals arc in terms of degrees over 360 times the circumference, 2 pi r. Notice I'm using the 2 pi r, not the pi d, because they're giving me or asking me about the radius. Okay, so let's fill in what we know, and that's the main step here. Write down the formula, fill in what you know, solve for the unknown variable. The arc length was 12 pi, and the arc degrees, they did tell me that, 144 divided by 360 times 2 pi r. It's the r they don't tell us about. We need to figure it out. Let me see if I can reduce this a little bit. Let's just see if, yeah, okay, so I want to see if 360 is divisible by 144. In other words, whoops, boy, I have a hard time with this calculator. All right, 2.5 times, that's kind of goofy. Okay, thinking out loud here. Okay, well, you know what I'm going to do? First thing I'm going to do is I'm going to divide this side by 2 pi. I'm going to divide this side by 2 pi. That cancels that out, and 12 pi divided by 2 pi, well, the pi's cancel each other out. 12 divided by 2 is 6. So now I have this much simpler expression. And when you want to get rid of this coefficient here, it looks a little weird, but I'm basically dividing by this weird fraction. And we learned a long time ago, 5th grade to be honest with you, that when you divide by a fraction, it's the same thing as multiplying by the reciprocal. You're like, I don't know what that means here. What about keep, change, flip? So we have to do this. So dividing by this fraction was the same thing as multiplying by the reciprocal. So we're going to do, let me clear this. So I got 6 times 360. That's my numerator. And I'm going to divide it by the 144. I don't think that worked. My calculators, I'm not used to this. Calculator up here, 360 times 6 equals, I'm going to divide that, I don't think it picked up my divide, by 144, that's 15. So this all came out to 15. And my unit of measure is, it's a radius, it's in centimeters, and there it is. Alright. Have fun, replay it if you need it. See you later.